So when we're trying to determine the sequence, we want to be looking for the pattern that's occurring in each of these terms. And one thing that is helpful is to, above each of these terms, write n equals 1, 2, 3, 4, and that just represents the first term, second term, third term, fourth term. Another thing that we can do here is think about this as 5 over 1. And if you look at each of those terms, they all share that numerator of 5. So we're going to set this up by starting with a sub n equals 5 over. Now, in terms of the denominator, we've got 1, 6, 36, 216. Those are all powers of 6. 1 is 6 to the 0 power, 6 is 6 to the first power, 36 is 6 squared, and 216 is 6 cubed. So it's going to be 6 to some power. Let's start with 6 to the n and see if that works. Well, here, 6 to the first wouldn't work for that first term because we need it to be 1. So we really need to have the first term have an exponent of 0, the second term have an exponent of 1, the third term have an exponent of 2. So that comes from just making that n minus 1. You're subtracting 1 from the term. And then, if we look at that fourth term there, if we put 4 in for n, we get 4 minus 1, which is 3. 6 to the third is 216. Now, letter B is an interesting one because, you might look at it and say, well, why are there some that are square roots, some that are not? Well, again, if we think about this as n equals 1, 2, 3, 4 for first term, second term, etc., if we look at the second and the third term, you're taking the square root of n. Does that same thing work if I take the square root of 1? Is the square root of 1, 1? Answer's yes. Is the square root of 4, 2? Answer's yes. So for this one, it would just be a sub n equals the square root of n. And then for the third example here, if I look at the pattern here, and I'm still going to write n equals 1, 2, 3, 4, each of those terms have a difference of 8. So 5 minus 8 is negative 3. Negative 3 minus 8 is negative 11, and this is actually called an arithmetic sequence, which we're going to talk a lot about in the next target. But if we were to plot points like this, they would form a line that has a slope of 8. So we can say a sub n equals negative 8n, and you can do a couple of things here. You could actually use slope-intercept form or point-slope form to get it, but you could also say, well, if I take negative 8 times 1, that gives me negative 8. What do I need to add or subtract to it to get 5? Well, to get from negative 8 to 5, you'd have to add 13. And then if we check that, negative 8 times 2 is negative 16, plus 13 is negative 3. Negative 8 times 3 is negative 24, plus 13 is negative 11. So it does keep working. But if you wanted to use point-slope form for that one, I'll show you how it works here quickly. And so we know the difference is 8, so our slope is negative 8. And then if we, let's take the fourth term, so that would be y minus negative 19 or y plus 19 equals negative 8, and then x minus 4. And if you went ahead and simplified all that, you would get negative 8x plus 13, which we would then write as negative 8n plus 13.